In this lecture video, we'll learn about quadratic functions and follow right along with the examples in your Chapter 6, Section 7 lecture notes. Once we had learned about linear equations, we turned our attention towards linear functions. Those are functions of the form f of x equals mx plus b. Now that we've learned a lot about quadratic equations, we will talk about quadratic functions, which are functions of the form f of x equals ax squared plus bx plus c, where a is a real number other than 0. Let's take a look at this example. We have f of x equal to x squared plus 12x minus 52, and we are asked to find f of negative 5. That is, we need to evaluate the function when x is equal to negative 5. F of negative 5 is equal to the function f of x with negative 5 substituted for x. So instead of x squared, we have negative 5 squared. Instead of plus 12x, we have plus 12 times negative 5 and minus 52. Negative 5 squared is negative 5 times negative 5, or positive 25. Positive 12 times negative 5 is negative 60. And 25 minus 60 minus 52 is negative 87. Let's go on to example 2. In this example, we are asked to find all values of x for which f of x is equal to 0. If we want f of x to equal 0, we can start by replacing the function with its formula. That means that we want x squared minus 17x plus 72 to equal 0. Now we have a quadratic equation that we can solve for x. Let's factor the left side. With a leading term of x squared, we know that the variable term for each of these binomial factors will simply be x. Now we need to find two values that have a product of 72 and a sum of negative 17. Since these two values will have a positive product but a negative sum, we need both values to be negative. The two values that will work in this case are negative 8 and negative 9. Negative 8 times negative 9 is positive 72, and negative 8 plus negative 9 is negative 17. Now that we've factored this quadratic expression, we can set each factor equal to 0. If x minus 8 is equal to 0, then x must be equal to positive 8. And if x minus 9 is equal to 0, then x must be equal to positive 9. So the two values of x for which f of x is equal to 0 are positive 8 and positive 9. Let's take a look at example 3. Example 3 is similar to example 2, but instead of finding values of x for which f of x is equal to 0, now we want to find values of x for which f of x is equal to 58. So we will again start by switching out the function for its formula. That is, we want x squared minus 7x minus 20 to equal 58. Subtracting the 58 from both sides, we can have this as a quadratic equation in standard form. We'll have x squared minus 7x minus 78 equals 0. Now let's try to factor this quadratic expression on the left side of the equation. With x squared as our leading term, the variable term for each binomial factor is x, and we need two values with a product of negative 78 and a sum of negative 7. Since we have a negative product, we need one factor to be positive and one to be negative. Let's run through our factors of 78 and see if we can find the pairing that will give us a sum of negative 7. There's 1 times 78, 2 times 39, 3 times 26, and 6 times 13. Can you tell which pair of factors we should use and make one of them positive and one of them negative? 6 and 13 have a difference of 7. So if we make 6 positive and 13 negative, we'll have a negative product of negative 78 and a negative sum of negative 7. So our binomial factors are x plus 6 and x minus 13. Now we'll set each of these factors equal to 0 and solve for x. X plus 6 can equal 0, or x minus 13 can equal 0. If x plus 6 is 0, x needs to be negative 6. And if x minus 13 is 0, x must be positive 13. So the values for x for which f of x is equal to 58 are the values negative 6 and positive 13. Before we go on to our last example, let's take a look at some graphs of quadratic functions. All quadratic functions have the shape of a parabola. The first one is the most basic form of a quadratic function. This is f of x equals x squared. It's a parabola that opens up and crosses the x and y axis at the point 0, 0. We can also have quadratic functions that are a parabola that opens down or is in a different location on the graph. Quadratic functions are used in many types of applied problems. Think about how this parabola opening down can model an object being launched into the air, reaching a maximum height, and then returning to the ground. Let's take a look at an example. In example 4, we have that a slingshot fires a ball upward from a roof that is 64 feet above the ground. The initial velocity of the ball is 48 feet per second, and the height of the ball in feet after t seconds is given by the function h of t is equal to negative 16t squared plus 48t plus 64. The first thing we need to figure out is how high is the ball after 2 seconds. Since the function gives us the height of the ball in feet after t seconds, we have that t is equal to 2. With t equal to 2, h of 2, or the height when t is equal to 2 seconds, is equal to negative 16 times 2 squared plus 48 times 2 plus 64. This becomes negative 16 times 4 plus 96 plus 64. This gives us a total of 96 feet. That is 2 seconds after the ball is fired out of the slingshot, it reaches a height of 96 feet. So let's look at our second question. How long will it take for the ball to land on the ground? If the ball is landing on the ground, then it has a height of 0. That is, h of t is equal to 0. And we need to find the value of t for which h of t is equal to 0. Let's first substitute our function for its formula. Negative 16t squared plus 48t plus 64 is equal to 0. Solving this quadratic equation will give us our values for t. In factoring the left side, let's first look for a greatest common factor for these three terms. All three terms are divisible by 16, and we can factor out a negative 16 to make our leading term positive t squared. Factoring out negative 16 leaves us with t squared minus 3t plus 4. Now let's factor t squared minus 3t plus 4. We need two values with a product of positive 4 and a sum of negative 3. This will be negative 4 and positive 1. Now that we've fully factored the left side of this equation, we can set each factor equal to 0 and solve for t. If t minus 4 is equal to 0, then t must be equal to positive 4. And if t plus 1 is equal to 0, then t must be equal to negative 1. So we found two values for t so that h of t is equal to 0. Let's think about the context of our question to figure out which of these answers is correct. The question is, how long will it take for the ball to land on the ground? A time of t equal to negative 1 doesn't make any sense in this case. That's negative 1 seconds, or 1 second before launch. T equal to 4 would be more appropriate. That would be 4 seconds after launch, coming back down to the ground. So our answer here is t equal to 4 seconds, or 4 seconds after launch, the ball returns to the ground. Let's sketch a picture of this function. Looking at the first sentence, we're told that the slingshot fires the ball from a roof that is 64 feet above the ground. That means that at time 0, when t is equal to 0, the ball starts at a height of 64 feet. We also learned that it is launched upward, so we expect our graph to begin by increasing. We also calculated that when t is equal to 2 seconds, the ball was at a height of 96 feet. So we can add that point to our graph. When t is 2, h is 96. Finally, we learned that 4 seconds after the slingshot fires the ball hits the ground. So we can add that point to our graph. We need more information to graph this function more accurately, but here's a sketch of what this function looks like. Notice that the reason why we also got a solution of t equal to negative 1 is if we drew in the rest of this function, we would have a second solution for h equaling 0 when t is equal to negative 1. This also brings up an important point about context when doing applied problems. When you're stating the solution to an application problem, make sure you read the context and that your solution makes sense. Giving a solution of t equal to -1 in this case does not make any sense with the context of the problem. So take that extra few seconds and make sure that the solution that you got fits the scenario. And that will conclude this lecture video on quadratic functions.